Hi guys, and welcome to another video. And today we are going to be looking at Mathematics Paper 1, November 2023. And this is the question that came out in the grade 12 examination, question 7 last year, right? So the first question that was there in 7.1 is determine f prime x from first principles if f of x equals to minus 4x squared. So when they say first principles, it means now that we need to use the formula, and the formula is found on our formula sheet, and we can go to our formula sheet quickly. And if you look at your formula sheet, as you can see here, you can easily pick out your formula from here. The required formula is this one here. So we're going to copy that formula down. F prime x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h. And now we're going to go back to our question and let's write that down. So for 7.1, we're going to firstly write down the formula f prime x equals to the limit as h approaches 0 of f of x plus h minus f of x all over h, and that's must be written first, the formula, and thereafter now we are going to substitute. So let's just go a little bit to this side, and we're going to write down limit as h approaches 0. F of x plus h is now wherever we got x here, we're just going to substitute x plus h into our formula, our given equation that's given to us there, which is f of x equals to minus 4x squared. So let's write that down. So we got minus 4 into x plus h all squared minus f of x. So use brackets now. What is f of x? F of x is this, minus 4x squared. So write that down, minus 4x squared minus 4x squared. So make sure you're using brackets because you can see what's going to happen here. When you open these brackets out in your next step under simplification, you're going to get a negative times a negative, which is now going to be positive. So let's complete this. So that's over h. So we're just substituting now, minus 4 into x plus h all squared minus f of x, which is minus 4x squared all over h. So remember that this is just substitution. So always write the formula down first, do your substitution, and now we are going to do our simplification. Remember that we must retain limit as h approaches 0 right up until the end, when we are only after we cancel this h here in the bottom, then only now we can leave that limit as h approaches 0 out. Okay, so we're going to now say limit as h approaches 0, and now let's open this brackets out. So it's going to be minus 4 into, now x plus h all squared. So there's various ways in which now, squaring a binomial we've done now, well, from grade 9, x plus h all squared. We can use the formula, or rather the rule, which is square the first term, which is basically x squared, double the product, which is first term times second term times 2. So that'll be plus 2xh, and then square the second term, which is h squared. Okay, but having done this now, if you've done this in your preparation and you've done it quite a lot, you'll see that this is quite common. And you can also use the FOIL method here, which is basically x plus h, and then you're going to say x times x is x squared, and then you're going to get plus xh, and then you're going to get here plus xh again, plus xh, and then plus h squared, which is going to give you the same thing, x squared. And then that's going to be like terms. We're adding the like terms, plus 2xh, and then plus h squared. So learners normally will just memorize this, that x plus h all squared is x squared plus 2xh plus h squared. So we can just simply just write it down there, x squared plus 2xh plus h squared. So that was just the working, and this you can just do under doodling. You can do it on a rough piece of paper or at the back of your answer booklet in your examination. If for some reason you forget what x plus h all squared is, then minus is plus, so now that's going to be plus 4x squared. So minus times minus is plus, and now that's going to be all over h. Okay, so this we're still under the simplification now. Then our next step will be to open out these brackets. Always check your work. Always check to see that you are on the right path here. Okay, so now we're going to take minus 4 into the brackets. Minus 4x squared minus 8xh minus 4h squared plus 4x squared. Okay, so that's what we are left with there, all over h. So you can clearly see now that we can cancel minus 4x squared and plus 4x squared, which leaves us now to remove h as a common factor there. Okay, and remember now we're not looking for the highest common factor. We're just looking for a common factor of h, so that we can now just cancel that denominator. So we'll say limit as h approaches 0, and we're going to take out h as a common factor there, and we're going to be left with minus 8x minus 4h all over h. So you can now clearly see what's going to happen. You can cancel the h that you removed as a common factor, which is h, and h cancels. So now we are left with the following. We're left with minus 8x minus 4h. So therefore now when we substitute h equals to 0, this now becomes 0. Minus 4h, that becomes 0 there. And what are you left with? You're left with minus 8x. So at this point now, you can now conclude that, therefore, the derivative, so you can now say, therefore, f prime x is going to equals to minus 8x. And that is our solution. So if you look at it, simplification, we're canceling that, and then we got our final answer. So this can be a 4-mark question. It can also be 5 marks if they're going to give you 1 mark for the formula. So it's basically just between 4 and 5 marks. Now, if it's 5 marks, then definitely, right, 1 mark is going to be for the formula, then 1 mark for simplification, and so on and so forth. So make sure that you don't leave any steps out. So therefore, finding the derivative from first principles here of minus 4x squared is now going to give us minus 8x. And remember now that we can always check our answer using the rule. Okay, remember the rule is as follows. If f of x equals to kx to the n, then f primed x equals to k times n x to the n minus 1. So 2 times negative 4. So therefore you can say, therefore, f prime x equals to 2 times negative 4 is negative 8. X, now you're going to subtract 1 from there. So 2 minus 1 is 1. So you're going to be left with that, minus 8x. So you can always check your answer to see if you got the correct answer using the rule. So there's the rule for finding the derivative using the formula. But remember now that this is only a check. We have to use the formula when you are finding the derivative from first principles. So we have to follow all of these steps, write the formula, do the substitution, simplification, removal of the common factor, and cancellation of h in our denominator, substitution of h equals to 0, and coming to a conclusion, which is our final answer, which is f primed x equals to minus 8x. Learners, that's our first question there now answered. Okay, negative 8x is the answer. Let's look at the next one. So in the next question, we have 7.2.1. Determine f prime x if f of x equals to 2x cubed minus 3x. So here now, for these two questions, we have to use the formula, which I already wrote down here, which is if f of x equals to kx to the n, then f primed x, which is our derivative, is going to be k times n times x to the n minus 1. So you're going to multiply your exponent or power here times the coefficient, and you're going to subtract 1 from your power or exponent. Okay, so let's have a look at that. So we'll write down the question first, 7.2.1. So in 7.2.1, let's write down our question, f of x equals to. And our question is as follows. So we've got 2x cubed minus 3x You've got 2x cubed minus 3x, 2x cubed minus 3x, and that's our question. So you can see now that it is in the form of kx to the n. So that's one of the things now that we must make sure that when you are finding the derivative using the rule f of x, that each term has to be in terms of kx to the n. So we got kx to the n. So here you've got kx to the n, kx to the n. Okay. Now there are specific rules when it's not kx to the n, and I will demonstrate that as we encounter that type of example. So therefore now f primed x equals 2. So we can just apply the rule as I've written it down here. So now that's going to be 3 times 2, which is 6x, and then you're going to subtract 1 from your index here, or exponent, which is 3 minus 1 is 2. So that's going to be 6x squared. And here you're going to be left with, remember the power there is 1. 1 times minus 3 is minus 3. And then if you subtract 1 from here now, remember x to the 1 minus 1 is x to the 0. And remember that x to the 0 equals to 1. Okay, so one of the things that we learn when we're doing this particular section is that the derivative of a constant is 0, and also the different rules that we must learn when we are finding the derivative. So one of the things is that when you got negative 3x and you find the derivative of negative 3x, you're going to be left with minus 3, because remember now that 1 times negative 3 is negative 3, and then you're going to be left with x to the 1 minus 1, which is x to the 0, which is equals to 1. So this will be our solution, and this will be 2 marks, 6x squared minus 3. Okay, let's look at the next question, and our next question is 7.2.2. So this is another notation that we can use, d subscript x. D subscript x is the same as saying f primed x, okay? And that is find the derivative here. So our question here is 7 times the cube root of x squared plus 2x to the minus 5. So that's our question, our next question. This is 3 marks. So we'll write our question down here, 7.2.2. Let's write that down. So we've got, so we can write it as follows. We'll say 7 times, so here now we've got 7 times, so let's write it as y equals to 7 times the cube root of x squared plus 2x to the minus 5. Okay, so we've got 7 times the cube root of x squared plus 2x to the minus 5 equals to, now you'll see here that you've got a root. Now when you've got a root, this is the rule that you're going to use to now convert that root to kx to the n. Because remember that in order for you to find the derivative, it has to be in this form, kx to the n. So the rule that we use here is simply, I'll write it down here, which is when you got the nth root of x to the m, it's equal to x to the m over n. So you take that, your power there, and you divide it by your root. So it'll be x to the m over n. And this is a very important rule now when we're converting that. So we're going to do that now. We're going to use that exact rule there. Okay, so you can just quickly take that down. So we're going to be left with the following: 7 times x to the 2 over 3. So you're going to be left with 2 over 3. And then here now we've got plus 2x to the minus 5. Now you'll see that all your terms, your two terms here are in the form kx to the n. So this is kx to the n, kx to the n. So only now we can now find our derivative. Okay, so this, remember, is still in terms of y. Okay, we can call it y, it's fine. Okay, and because now we're going to find our derivative with respect to x, because remember our symbol here was dx, or the notation I should rather call it dx, f prime x, and dy dx all mean the same thing. You're finding the derivative with respect to x. So now we can find the derivative. So we got 7 times x, or 7x to the 2 over 3 plus 2x to the minus 5. So now we'll say, therefore, dx. We're finding the derivative with respect to x. So 2 over 3 times 7. Okay, remember the power times this coefficient, or the exponent times the coefficient. Right? Now, if you want, if you don't like working with fractions, you can just say 2 over 3 times 7. You can say, let's do that again. 2 over 3 times 7 equals to 14 over 3. So you can write 14 over 3x. Now you got 2 over 3. Remember, you need to subtract 1 from there. Okay, and for some reason, if you don't like working with fractions, you can just say 2 over 3 minus 1. Remember, we subtract 1 according to the rule. And then we got minus 1 over 3. So we're going to write minus 1 over 3. So that's already done now. We found the derivative there. Now let's find the derivative of our next term. Minus 5 times positive 2 is minus 10x. And minus 5 minus 1 will give you minus 6. And I'm not going to use the calculator there, right? So that's obviously we're not using, right? We're not working with fractions. You don't have to use a calculator, but I'm just saying, in an examination situation, if you're under a little bit of pressure or stress, or you want to check your work, remember, we normally use a calculator as a checking mechanism. Okay, so it's left entirely up to you. So that will be our solution there. And remember, it's not necessary now for us to write with positive exponents, okay? Because remember, now this is a 3-mark question. So the mark allocation would be as follows. For you to go from there to there is, right, 1 mark. Basically applying that rule, because writing this in terms of kx to the n. And then you'll get 1 mark there and 1 mark. This is the 3-mark question. Like in the previous question, here, this is 2 marks. You'll just get 1 mark there and 1 mark there. All right. Okay, let's look at our next question. So in our next question, we have, it says here, for which values of x will the tangent to f of x equals to minus 2x cubed plus 8x have a positive gradient? For which values of x will the tangent to f of x equals to minus 2x cubed plus 8x have a positive gradient? Now, positive gradient now means that the tangent must have a positive, right? It's going to be positive. Your tangent, the gradient of that tangent is going to be positive. Now, first of all, we'll learn when we're doing cubic functions that this a value is negative, okay? So if the a value is negative, now it's right. Basically, I'll draw it for you how it's going to look. It's going to look like that, okay? So it's going to start off by going down. It's going to be negative, positive, and negative. Let's draw it bigger, and then we'll see from there. So I'll read the question one more time. For which values of x will the tangent to f of x equals to minus 2x cubed plus 8x have a positive gradient? Now, that's what we need to concentrate on there as well. All right, so let's look at that. So 7.3, we're going to do it as follows. Let's see. So we're going to say 7.3, and our question is as follows. Remember that the gradient m equals to f prime x at x, and something that we need to know that at our turning point, remember that our gradient m equals to 0. So our gradient equals to 0 at our turning point, okay? So at your turning point. Okay, so your gradient there is equal to 0. So that's where, right, everything is going to change. So this is important for us to know. The gradient m equals to f prime x at x. Now, let's look at the following. So to answer this particular question, let's write that function that we have down there. So our function is f of x equals to minus 2x cubed plus 8x. So f of x equals to minus 2x cubed plus 8x. So we got minus 2x cubed plus 8x. So now if we find the derivative here, remember that when you find your derivative, you're going to find the x values of your turning point. And that's important because at the x values of our turning point, remember that our gradient is equal to 0 there, right? And on either end of that particular point, you're going to now find that your function is going to be increasing and decreasing. So let's work out that first. So firstly, we're going to say f prime x equals to minus 6x squared plus 8. Okay. Now, remember that I wrote down over here, and I'll write it down again. Remember that you're going to now say that, remember, f prime x equals to 0. So we're going to say, why right now, why am I saying that? Okay, we want to find the turning point or the x values of our turning point. So m equals to f prime x. Okay, and remember that that's now going to be 0. Okay, so we need to say 0 equals to minus 6x squared plus 8. So we want to find the x values of our turning point. Okay, not necessarily the coordinates, but the x values, because that's where change is going to happen. And I'll draw the graph and show you what happens there. So why 0? Because remember that your gradient now, to find your turning points, okay, your gradient must be 0 at that particular point. So f prime x equals to 0. Now let's solve for x. So we're going to get the following. We're going to get 6x squared equals to 8. And we're going to get x squared equals to 8 over 6. And then now you're going to get x equals to plus minus the square root of 8 over 6 equals 2. So let's put that in the calculator. So we'll get there the square root of 8 over 6. 8 over 6 equals 2. Let's see what we get there. All right, so we got 2 root 3 over 3. So that's going to be now, so we got plus minus 2 root 3 over 3. Okay, so we got, let's do that again. We got the square root of 8 over 6. So the square root of, let's do that one more time, 8 over 6 equals 2. Okay, 2 root 3 over 3. That will be fine. Okay, so let's see. So what's happening now? So firstly, I told you that our function was f of x equals to minus 2x cubed. So minus 2x cubed plus 8x. So that means this particular function is now going to look like this. Remember that because a is less than 0, therefore the cubic function now is going to look like that. It's going to be negative, positive, and negative. And remember now at your turning point, so there's your turning point, it's going to be here. So here you've got minus 2 root 3 over 3. So it's going to be minus 2 root 3 over 3. And then here you're going to have positive 2 root 3 over 3. So that's going to be 2 root 3 over 3. So what's going to happen now? Remember at your turning point here, okay, your gradient is equal to 0, right? See, because you can see if you have to draw a tangent here, m equals to 0. If you have to draw a tangent there, you'll see m equals to 0. So here, if you have to draw a tangent, you'll see that's going to have a negative gradient. If you have to draw a tangent here, that will be a positive gradient. If you have to draw a tangent here, that will be a negative gradient. Therefore, minus, plus, minus. But it all comes from here. Remember that if a is less than 0, your graph is going to look like this. So it's going to go down, then up, and then down again. Now, if you want to answer the question, then that's exactly what we want to do. The question clearly asks us where it's going to have a positive gradient. For which values of x will it have a positive gradient? So the values of x for which it will have a positive gradient is going to be between these two x values here. So we're going to write it as follows. We're going to say, therefore, x must be greater than minus 2 root 3 over 3 and less than 2 root 3 over 3. So between those two x values, our gradient of our cubic function here is going to have a positive gradient. And learners, that will be our solution to this particular question. Okay, for 13 marks, last year's November paper 1, 2023. Okay, so I'll catch you then in the next video.